Hello dear students. In our last part of video, we have discussed chemical properties of aliphatic amines. Today we are going to study electrophilic substitution. That means today we are going to study chemical properties of aromatic amines. All of us know from our basic language that NH2 group is a strongly deactivating group. And therefore it is orthopara directing group. So all the products will be directed towards, or the incoming nucleophile will be directed towards ortho or para position. Now from our basic knowledge, we know that 5 types of electrophilic substitution reaction: halogenation, nitration, sulfonation and Friedel-Crafts reaction. So let us begin one by one. The very first reaction that we are going to study is halogenation. First one, direct bromination. We can add direct halogen to aromatic amine, or we can add it an indirect way also. So when it is a direct bromination, aniline is treated with bromine in polar medium like carbon tetrachloride, carbon disulfide, etc. And we get a monosubstituted product. This will be 2,4,6-tribromoaniline. So through direct bromination we get tri-substituted product, but if I want monosubstituted product, then I need to do indirect bromination. Indirect bromination, for that I have to mask this NH2 group so that we can control its activity, and therefore we are carrying out first of all masking by using acetic anhydride. Aniline is treated with first of all acetic anhydride in presence of pyridine. So when this reaction is carried out, we get acetanilide, NHCOCH3. So now we have masked NH2 group, and now we will carry out reaction of acetanilide with bromine in acetic acid. We will get monosubstituted product, and obviously need not to say that para product will be a major product. Its hydrolysis gives us NH2 group back. So finally we get the product para-bromoaniline. And therefore this reaction I will mark as important one because it requires steps. NH2 group will be masked by using acetic anhydride, and it forms acetic anhydride. Now what happens during this reaction which do not allow NH2 to take part in the reaction? The reason lies in the structure of NHCOCH3. Let us discuss the structure of NHCOCH3. This is the structure of NHCOCH3. From the structure we can say it undergoes hyperconjugation, or can say resonance, creating the charges on it. So positive charge on the nitrogen and negative charge on oxygen. And because of this resonating structure, now NH2 will not be allowed to take part in the reaction. The lone pair which is present on nitrogen, it will not be available for the reaction. As a result, reaction will not take place and directly para substitution will take place. So we can say we are reducing the deactivation of NH2 through this. The same way we will be studying nitration, direct nitration and indirect nitration. In nitration method, aniline is first of all treated with nitrating acid mixture, and the interesting thing is that along with ortho and para product, we get some meta product also. Otherwise, we know that NH2 is ortho para directing, but in this case, along with ortho and para, we get meta product also. Reason lies in the fact that when this nitration process is taking place, during the reaction mechanism, anilium ion is formed, and this anilium ion is basically meta directing, and therefore we get all these three types of product. Meta product is also formed along with ortho and para. This question is one of the important give reason question, that why meta product is formed or why meta nitroaniline is also obtained along with ortho and para nitroaniline during the nitrating mixture. While carrying out nitration. Now let us see how do we carry out indirect nitration. It will be the same as we have carried out indirect halogenation. So first of all, masking of NH2 group by using acetic anhydride in presence of pyridine. So we get acetanilide, and this acetanilide now will be treated with nitrating mixture. We have to take care of the temperature condition, and we get nitro product, obviously mono-substituted product, and this will be para-nitroacetanilide, which on further hydrolysis gives this NH2 back, and we get para-nitroaniline. Bromination, direct or indirect, nitration, direct or indirect. These are very important questions and frequently repeated question during your board exams. The next electrophilic substitution reaction that we are going to study is sulfonation. So aniline, or I'll say 1 degree aromatic amine, when it is treated with H2SO4 followed by heating at 453 to 473 Kelvin, we get sulfanilic acid. Most of the time in board exams, when the question is asked, convert aniline to sulfanilic acid, the students don't remember the structure of sulfanilic acid, and therefore they are not able to write the conversion. Sulfanilic acid means SO3H group attached with aniline. Okay. Now the interesting thing with this sulfanilic acid is that it can change or it can undergo rearrangement, forming a zwitter ion. Now this zwitter ion word is derived from the Greek word meaning hybrid ion. This will be studying again in the chapter biomolecules. So sulfanilic acid can also form zwitter ion. These are the three main electrophilic substitution reaction. Let us move forward for Friedel-Crafts reaction. Last two electrophilic substitution reaction for aromatic amine are Friedel-Crafts alkylation and acetylation. But the interesting thing is that aniline do not undergo Friedel-Crafts reaction. So you don't have to learn Friedel-Crafts alkylation or acetylation reaction. Now why they do not undergo alkylation or acetylation reaction? We know that aniline is basic in nature, and during these two reactions we are using aluminum chloride which acts as acid. So actually a reaction between acid and base takes place. Nitrogen of aniline, which is actually basic, will react with aluminum chloride. As a result, it acquires positive charge and the salt is formed. So aluminum chloride, which was supposed to act as a catalyst afterwards, or it was acting initially Lewis acid, instead of that it react giving a salt. and we do not get the final alkylated or acetylated product. Therefore, aniline do not undergo Friedel-Crafts reaction. So this is again I will say your important give reason question. Okay. Our next topic is comparison of basic strength of aliphatic amines and ammonia. So this topic we are going to study in our next upcoming video. Today we have studied electrophilic substitution reaction of aromatic amines. Thanks for watching. Have a nice day.